Let's take a look at branching. So branching allows us to make decisions with our code. It basically allows us to choose which code to run, and that allows our computer programs to make decisions based on inputs. We're going to use if-else statements. So if statements in our code and create branches in our code using logical operators. We'll be able to detect various types of ranges, and you'll see what that means as we move forward. We'll also learn to use switch statements and to compare strings, whether strings are equal, alphabetical order of strings. We'll understand character operations and the difference between characters and strings, and we'll learn to compare floating point numbers, among other things. A couple of things here. As always, this lecture is an overview of the chapter in your Zybook. This is chapter 4. You're expected to complete the Zybook reading assignments, the reading participation and challenge activities, as you move through the chapter while you listen to this video. It's the best way to do it. You get points awarded for the various activities that you complete prior to the due date. And then there are also Zybook labs, which, as you probably know by now, need to be completed as well prior to the due date. So a lot to do. So it's a good idea to start early and move through this fairly quickly. Now, these lectures may not cover all sections. They cover the most important, well, I shouldn't say that. They cover the sections where you might need a little support as you go through the section, a little explanation. Some sections you probably don't need that explanation, or it isn't appropriate really to lecture on those there. Let's get started and look at some basics about branching. So if you look here, the blue diagram is a flow chart. And the flow chart begins, this is program flow. It begins here with the oval and it proceeds through the square. Um, so we have a rectangle, I'm sorry, not a square, it's a rectangle. So in the rectangular box, we're setting the value of hotel rate to 155. Then we get a user input in this parallelogram. So user age equals get next input. And then the diamond is a decision box. Okay, so user age is greater than 65. That's a test of user age. If the value in the user age variable is greater than 65, if this evaluates to true, then we take the true branch and we set the hotel rate equal to hotel rate minus 20. If it's false, we skip that and just go down here and put the rate in the output and the hotel rate in the output. So you can see that this decision box allows us to do one set of code in one condition and another set in another. This evaluates to true or false. So we're just testing this Boolean expression. This is a relational expression. It's greater than for true or false. Sometimes we're interested in sort of testing multiple values, one after the other. So in this case, we're checking to see what anniversary is happening for some newlyweds. Or, well, they're not necessarily newlyweds after they've been married for a while. So we set the number of years they've been married to the input. In other words, we input the number of years, put it in the num years variable, and then we test it. So if num years is equal to 1, we put newlyweds to the output. So we print newlyweds. If that's false, then we check is num years equal to 25. If it is, then we put silver to the output because it's the silver anniversary. If that's false, we test if it's equal to 50. And if that's true, we put golden to the output. And if it's false, we put congratulations to the output. So it allows us to test each of these in sequence, and whichever one is true. You'll notice that if num years equals 1, if we test the first one, Then we put newlyweds to the output, and we skip all these other tests. So the coding that allows us to do that is something called an if-else statement. Okay, if this is true, do this, else do this one. If this is true, do this, else do this one. Okay, so else is an optional part of an if statement, and you'll see how this works. We can use this if statement to test a Boolean expression and then execute the code inside some braces if this Boolean expression is true. This is the equality operator. It evaluates whether one thing is equal to another. Notice it's an equal sign. That's different from the assignment operator, which is an equal sign and just assigns a value to a variable. This tests to see if one thing is equal to another. Okay, we have this code example. So look how this works. So we're looking at some years married and that sort of thing, and we're going to vary a hotel rate based on that, a hotel room rate based on the years married. So give someone a little extra value if they've been married for a long time, or if it's a you know, that sort of thing. So let's look at our program. First thing we do is we scan in a value. We have a scanner here, right? We set up our scanner. So our pointer to the scanner, right, is SCNR. So that's our scanner variable. Then we declare a couple of integers, hotel rate and the number of years, and we initialize the hotel rate to 150. By the way, you could do it here too. You could just say int hotel rate equals 150 in that one line if you wanted to. Now we print out a prompt, enter the number of years married, so our user knows to type something in, and then we call scnr.nextInt, and we execute this method nextInt, which causes the input to pause and waits for someone to type something in. Then we assign that value to num years. Now here's the if statement. That's just a little review. Here's the if statement. If num years is equal to 50, we're going to print congrats on 50 years of marriage. Okay. And then we set the hotel rate in half. We divide the hotel rate by 2. So hotel rate equals hotel rate divided by 2. So we give them a break on the hotel rate, and then we print out your hotel rate and then the rate that the hotel room is going to be. So we print out the hotel rate, and that's the output. So you can see it here. Enter years married 50. Congrats on 50 years of marriage. Your hotel rate 75. Okay. So here's the if statement right here. And also it's printed, it's sort of broken out here for you in terms of a little flow chart. But so if num years equals 50, if this evaluates to true, right, this is a relational expression. So it's just testing to see if the value in the num years variable is equal to 50. If it is, then you're going to do what's inside the curly braces. So you'll print out congrats on 50 years of marriage, set the hotel rate to hotel rate divided by 2. If this is not true, if this is false, you skip what's inside the braces and just go down here to this part and do it. So you don't execute what's inside the braces if this expression is false. And that's it. That's how this thing works. So what's the inequality operator? If we want to check if something is not equal, okay, we use this little exclamation point equal. Exclamation point means not, and then the equality sign, in this case, we're using this to be equal. So this inequality operator tests for inequality to see if they're not equal to each other, and it returns true if they're not equal or if they're different. A Boolean data type is a data type that has two values. It's either true or it's false, okay? So here are the equality and inequality operators in this little chart. So here's your equality operator, which is the equal sign, two equal signs, equal, equal. So A equal B means A is equal to B if that's true. So if X is 3, if we say X equal 3, that evaluates to true, and X equal 4 evaluates to false. Okay. And then in the inequality operator, it means not equal to. So X not equal 3 is false because we're assuming X is 3. X not equal 4 is true because it's not equal, right? We can also tack on this little optional else statement. So an if else statement just executes something if the expression is true. Otherwise, it executes something else. So let's look at the code. If div remainder equals 0, then print out user num is even. Else system out print line user num is odd, right? So if div remainder equals 0, if this evaluates to true, we do what's in the first set of curly braces. And then if it's not true, if it's false, we do what's in the second set of curly braces. So it's very explicit. Instead of just jumping past what's in the first set and executing the remaining code, we specifically execute the code inside the else statement and then proceed with the rest of the code. Now let's look at this structure. So this is very interesting. If this expression is true, then we will execute what's between these first braces, that first branch, and nothing else. If this is false, else, if this is false, then we test this expression. If this expression is true, then we do this, else we do this. And you can string as many of these as you want. So if this is true, do it, else do this. If this is true, do it, else do this one. And if you could have more else ifs all the way down through there. You can see how this is used here. If you've been married 1 year, print your first year, great. Else, if num years equals 10, print a whole decade, impressive. And you'll notice that only one of these will execute. If this one is true, if num years equals 25, then you just jump to the end, right? If the first one is true, you just jump to the end. Else means you only do this if this isn't true. So we can use this to detect ranges with branches. So in this little chart, we're trying to decide which team a child will play on, which sort of sports team a child will play on. So if you look at it, if the child's age is less than 6, no teams. Else, if the age is less than 8, we play on a U8 team. Else, if the age is less than 10, we play on a U10 team. Else, if the age is less than 12, we play on a U12 team. Now, I want to point something out about this. The order makes a difference. This has to be evaluated in order. What if I just came up here and I said if age is, forget these two lines right here, pretend they're not there, and I said if age is less than 10, well, you'd have 6-year-olds playing on a U10 team, right? So you have to test for them first before you get to 10. You have to test for 10-year-olds before you get to 12-year-olds. And remember, only the correct one will evaluate, right? But they do have to be in order or it won't work. So here's a flow chart that kind of shows that. And if you look at it here, we get the user age, and then you can just see if user age is less than 16, too young. User age is less than 25, insurance price is 4,800. But notice we have to test for 16 before we test for 25 because we have to make sure that they're not under 16. If we just tested for user age under 25 first, it would set the price at $4,800 for people who are under 16 and they can't even buy insurance. So that's why it has to be in order like that. Here are our relational operators. So a relational operator checks how one operand's value relates to another. It's like greater than, less than, greater than or equal to, less than or equal to, that sort of thing. So if A is less than B means A is less than B, and if that's true, it returns true, otherwise it returns false, and so on for each of these. This is less than or equal to, this is greater than or equal to. And that greater than or equal to and less than or equal to or greater than, that's very important. If you're testing two integers, you need to decide what to do in that condition where they're equal. So here's another code example. So again, we're doing the user age less than 16, and we print out insurance price equals 0. And so it's just basically the same thing. It just shows you how that works, right? And again, it has to be in the correct order. Let's look at logical operators. So logical operators include and, or, and not. And for the most part, these work just the same way that they do in English. So if I say, I'm going to the grocery and I'm going to the movies, and I get home and you say, hey, did you go to the grocery? And I say, yes. And you say, did you go to the movies? And I say, no. Then you know that I told you an untrue statement because I said I was going to do both of them. I used and. Okay. So this is a truth table. And truth tables allow us to define the outputs for various expressions. So if we have an A and B, so think of A as like going to the movies and B as going to the grocery. If they're both false, then I tell you A and B. I say, well, I'm going to go to the movies and I'm going to go to the grocery. And I didn't do either one of them, A and B. That's a false statement. I made a false statement. A is false and B is false, so the whole thing's false. Also, if I tell you I'm going to the movies and I'm going to the grocery and I come back and I didn't go to the movies, then I told you an untrue statement. I said I was going to the movies and going to the grocery. I didn't do one of them, so my statement was false. And means I do both, right? Just like in English, that's the way it works. So if A is false and B is true, then A and B is false. If A is true and B is false, A and B is false. The only time that A and B is true is when A is true and B is true, right? So and means they both have to be true. Or means that only one or the other of them or both of them are true for it to be true. So the only time an and is true is when they're both true. The only time an or is false is when they're both false. If I say I'm going to the movies or I'm going to the grocery, and implied in this kind of or is or both, then I as long as I do one or the other or both of them, then that's true. Otherwise, if I don't do either one, it's false, right? So as long as A is true or B is true or they're both true, and or is true. The only time it's false is when they're both false. And then not just sort of takes the inverse of the truth value. So if A is false, not A is true, and if A is true, not A is false. It just switches it. Okay. So now let's look here at some actual expressions. Now we don't use the word and or in Java. We have symbols for them. You know, we have operators, I should say, for them. But let's for now look at the words. So let's say x is 7 and y is 9, then x is greater than 0, that's true, and y is less than 10, that's true. So this whole statement, x greater than 0 and y less than 9 is true. This one is false. X is greater than 0, but y is not less than 5 because y is 9. So one of them is false, so it's false. And if you look over here at this or, x is less than 0 or y is greater than 10, neither one of those is true, so this or statement is false. But x is less than 0, that's false, or y is greater than 5, that's true. So this or, this whole expression, evaluates to true. And then in terms of not, not x is less than 0, x is less than 0 is false, so not x is less than 0 is true, right? So when you evaluate the whole thing, it evaluates to true because this just inverts that value of false. Here's a little chart that summarizes that for you. It just shows that the logical and is true when both operands are true. Logical or is true when at least one of them or both of them are true. And the logical not is true when one operand is false and vice versa. So sometimes we want to detect ranges using these logical operators, ranges of values. We want to test if somebody's age is between two values or something like that. So you see this in math a lot. So you'll see 10 is less than x is less than 15. So we're defining the range of values that are possible for x. X has to be greater than 10 and it has to be less than 15. So that's another way of sort of saying that. And if you look at the little chart right here, you can see that. So 10 is less than x is less than 15. If you're talking about integers, that includes 11, 12, 13, and 14. It doesn't include 10 and it doesn't include 15 because x is less than 15. It's not equal to 15. Okay. So how would you write that kind of in Java? Well, you would break it apart because you can't write this 10 is less than x, less than 15 in Java. So we would say 10 is less than x and x is less than 15. We do the first part, 10 is less than x, and the second part, x is less than 15. So we have to have this and operator right there. So see how that defines the same range. And if you look at the lines, 10 is less than x defines this. The and means it has to be both of these things, right? X is less than 15. So only when both of these things are true do we get this nice little range right here. So this nice little chart shows us our Java operators that we use to do this. The ampersand is the logical and operator. So A ampersand B will evaluate to true false depending on the values of A and B. So that's A and B. The OR is the two straight up and down lines, and that's the shift backslash key. It's what those two up and down lines. If you look on your keyboard, you'll see those. So we know where the ampersand is at. And then the logical not is an exclamation point. So this is A or B, and this is not A right here. So we can define ranges when we're defining ranges of values. We can do it either explicitly or implicitly. So if you're explicitly defining a range, you might say, else if x is greater than or equal to 0 and x is less than or equal to 10. So here's the lower value and then the higher value, and you're defining both of them. But look over here, we can say if x is less than 0, then it's negative. Else if x is less than or equal to 10. So the fact that it's greater than or equal to 0 is implicit in the way that the code is structured because we tested that first. So the order matters here. Here you need to have it in a logical order, but because you're explicitly defining the ranges, the order isn't as important. So we can detect ranges using logical operators in our code this way. So if user channel is greater than or equal to 2 and user channel is less than or equal to 499, then channel type is S. Otherwise, if user channel is greater than or equal to 1002 and user channel is less than 1499, channel type is H. And so you can see how that's done. It's the same thing. You're explicitly defining ranges using the logical operators in Java. So this is what the actual code would look like. Sometimes we want to define ranges that have gaps in them so that the range isn't all together. So if you look at this, for example, we're looking at ticket prices according to age. So that's just a handy example. So if user age is less than or equal to 12, the child discount, you get the child discount, and the movie ticket price is set to 11. Remember, you do all of the things inside this code block. Opening curly brace, closing curly brace. Else, if the user age is greater than or equal to 65, then you get the senior discount. Notice that there's a big gap in that range there. Less than 12, greater than 65. Otherwise, the movie ticket price is 14, and that's all of them. So you can have gaps in there. Again, this is an example where you have some gaps. And you'll notice up here we use an if else. So if office number is greater than or equal to 100 and office number is less than 150, it's a valid number. Else if the office number is greater than or equal to 200 and less than or equal to 250, it's a valid number. Otherwise, it's not valid. It's a bad number. Those offices don't exist. Now you can put that and combine that into one Boolean expression. So we can say if office number is greater than or equal to 100 and office number is less than or equal to 150, or the office number is greater than or equal to 200 and the office number is less than or equal to 250, then it's valid. So notice we put it all in this one if statement. We combined these two things and just used an OR operator. So you can put some pretty complex things combining relational and Boolean operators like that. Sometimes you just want to evaluate all of the if statements. In other words, no else. So if you look at this code, if user age is less than 16, print enjoy your early years, there's no else here, right? So it's going to evaluate this if statement, then it's just going to drop down and evaluate this one following it. If user age is greater than 15, print you're old enough to drive, right? So a lot of places are driving 16, right? Greater than 15, you're talking about integers here, so 16 is the next value up there. If user age is greater than 17, you're old enough to vote. If user age is greater than 24, most car rental companies will rent to you. If user age is greater than 34, you can run for president. Now, suppose that I enter a user age of 40, right? So is my user age less than 16? No, it's not going to do this. It's not going to print enjoy your early years. It's going to test this and it'll be false. If my user age is 40, this is true. It'll print you're old enough to drive. If user age is 40, it's greater than 17, so you're old enough to vote. It's greater than 24 in most car rental companies. So what's it gonna print? And you can see over here what happens when you do each of these. There's no else with these if statements here. That means that they'll all execute one after the other. In computer engineering, software engineering, computer science, if we say something is nested, we mean it's inside of another structure. So if you look, see the if statement here, if num items is greater than 3, here's the opening curly brace for that, and here's the closing curly brace. And inside of that code block is another if statement. So we would say there's a nested if statement, right? And you could have multiple nested if statements, but it would get kind of confusing maybe. So what is this? Well, what we want to express here is if num items is greater than 3 and the total cost is greater than 100, we're going to give you a 20% discount, sales discount of 20. So we have this outer if statement that tests if it's greater than 3, and then inside of that, we check to see if it's greater than 100. So if you have to buy at least 3 items, but if you do, if the total cost is greater than 100, you get this 20 sales discount. Else, if the total cost is greater than 50, you get the sales discount of 10. Okay. So how do we structure that? Well, we have an outer if statement that tests the first condition if it's greater than 3. And then if it is, that gives us the go-ahead to check for the other 2, right? So nested if statements. And then not only is it a nested if statement, it's a nested if statement with an else if right inside there. Now we could just write this out with logical operators, couldn't we? We could just have a Boolean expression that just kind of says it this way, and that would work as well. This table shows the precedence rules in order of precedence for arithmetic, logical, and relational operators. So the highest precedence are parentheses. So you can always control precedence with parentheses, right? So if you look over here, what's evaluated first? Well, normally addition comes after multiplication, but since we put it in the innermost set of parentheses, this will happen first. B plus C, followed by the multiplication, and then the minus will occur next. Okay, so we can control things, we can control the order of operations with parenthesis. Okay, The next thing that happens is the unary operator not. So if we have like not x, that's going to be evaluated first, no matter where it is in the expression. Okay, and then the others. The arithmetic operator precedence, we already kind of talked about it, but it's multiplication and division from left to right, modulo, and then addition and subtraction left to right. So if you look at this, the first thing that happens is 45 is multiplied by y, okay? Then the subtraction followed by the relational operator less than. The relational operators come next after the arithmetic operators. So you do your arithmetic first, then the arithmetic operators. Then the relational operators. So you have less than or equal to, greater than, and greater than or equal to in that precedence. Equality and inequality, you have the equality operator and then the inequality operator. And you can see how that's evaluated. So this expression is evaluated as x equals 10, followed by the inequality, and then the and. The last thing is the and. Logical and logical are last in order of precedence. So bitwise operators, I kind of just want you to know these exist and aware of them for now. But the way this works is that if you consider a number in binary, so say that A is the number 0101 in binary, which is actually 5 in decimal, right? So, and then B is 0011. So if you do A and B, what happens is each bit is compared and ANDed together. So the result of this would be 0001. Why is that? Because the first bit, the rightmost bit, B is a 1 and A is a 1, so A and B is 1. So that bit drops down as a 1. The others, if you AND them together, 1 and 0, consider 1 true and 0 false. If you AND these two things together, what do you get? You get false, right? Because they both have to be 1s in order for it to be 1. And that's all it does. It just compares them. This single straight line operator like this, that it's an OR with the same rules, but you do a bit by bit comparison. And XOR is a little bit different. Now, XOR, we might as well talk about it here. XOR is an exclusive OR. And you can use XOR in regular Java sorts of expressions as well. So XOR means one or the other, but not both. So it's only true when one or the other, but not both of them is true. So when you XOR this rightmost one, that's false. XOR and OR are different. Exclusive OR is the one we usually mean in English. So if I say to you, I'm going to the grocery and I'm going to the movies, you assume what I mean, and most of the time in English is I'm going to do one or the other of those things, but not both, right? Our little computer science OR that we discussed earlier means one or the other or both. This XOR, exclusive OR, means one or the other, but not both, okay? And that's not going to be super important to you for a while probably, but that's part of it. And then the bitwise not is the tilde, okay? And it just complements, changes each of the values. Like if it's a 0, it changes it to a 1. If it's a 1, it changes it to a 0 there. Okay. Now let's look at switch statements. So a switch statement can sort of do the same thing and similar to an if statement in a sort of an organized way. Okay. So it's good for doing things where you have well-defined sort of cases. And it's great for doing little menus and text on your screen, that sort of thing. So how does a switch statement work? Well, it basically checks for a match. So we're going to switch on the value of A right here. If A is 0, then we'll do case 0. We'll print 0. If A is 1, we drop down and do case 1 and print 1. So what it's doing is it's matching the value of A to this value right here, and then doing what comes after it before the break. So you have to have this little break right here because that's what stops the case from just continuing on down and doing case 2, so on. So if A is 1, okay, it'll match 1. It'll do whatever's inside here after 1 until it hits that break, and then it'll stop and it'll fall out of the case statement. So that's how that works. So this is just the general form of that switch. And so we have some expression up here, and then we have a constant, and that expression has to match one of these constants for that case to be executed. So here's a switch case. So let's take a look at it. So we're going to switch on dog age years, right? So we put in our dog years, how old our dog is, and then we're going to switch on the value of that variable. So suppose that I put in there 2. And so what happens is I compare dog age years, the value of the variable, and I find it down here in case 2, and it's going to print that's 24 human years, and then break and fall out of the switch statement. So fairly straightforward. Here's another example. This is with months. I encourage you to look through that. You'll notice it has dog age months, and it would include case 0, 1, and 2. So it would match on all 3 of these right here. It would match on all 3 of these if, and then print that's 0 to 14 months. So you can do a range with a switch statement too, although that's a little bit less usual. Okay, so let's talk about the Boolean data type. So Boolean refers to a quantity that has 2 values, either true or false. So if I define a variable as a Boolean, it can only be true or false. And I can write in there, I can write Boolean is raining equals true. So that's valid Java code. Boolean is raining equals 2. My variable is raining, and I'm setting it to true, which means it's raining, right? So that's really neat for writing cool code like that. And the Boolean with no capital letter is how you define a Boolean data type in Java. Okay, Boolean with a capital letter just refers to the fact that it's a Boolean type of variable, but if you want to write it in Java code, it has a lowercase. Why? Bool was a person, and that's why Boolean's capitalized. So here's an example of the Boolean data type and using it with variables. And this really is kind of cool because it makes your code very readable. You know, so I can say things like, I can define variables this way. So Boolean is large party, Boolean is weekend. So this is a reservation system in a restaurant, right? So we're going to print the day of the reservation and so on. So here's an if statement. If day equal F, day equal S, or day equals U, is Boolean equals true, or is weekend equals true. So we've defined the weekend there, right? Set it. Otherwise, is weekend equals false. So we can check and see if it's the weekend. And then save that value as a Boolean variable, true or false. And then can enter the party size. Is large party equals party greater than 6. Now notice this. So the user enters the party size, and we test that. In parentheses right here, we have party size greater than 6. This will return true or false based on whether the party size is greater than 6. And say it returns true, is large party would be set to true, otherwise it would be set to false. So we're testing right here on the right-hand side of that equality. Isn't that cool? And then setting it to this Boolean variable, which can be true or false. Now we can determine the wait time over here based on the day of the week and the party size. So we can write this if expression. If is weekend and not is large party, the wait time is 30. Now I want to point a couple things out. We're not writing if is weekend equals true. We don't have to write that because is weekend is either true or false already. We don't have to test to see if it's true. I mean, you could do that. You could say if is weekend equals true and not is large party, equals something. But you don't have to. You just say if is weekend, because is weekend is either true or false, and not is large party, so it's a small party. Wait time equals 30. See how cool that is? And you can read that code almost like it's English. Isn't that nice? Okay, let's talk about string comparison. So far we've compared numeric values. We compared integers mostly, and we just used the equal sign, equal to see if one integer is equal to the other, and so on, that kind of thing. Um, but we can't really do that with strings. So why not? Well, because a string is a string of characters. It's a whole bunch of characters in a row. And we actually, when we compare two strings, we're comparing each character in the string, one string, to each character in the other string and seeing if they're the same. Okay. Now, string is a class, and the string class has methods. And one of the methods in the string class is the equals method. And that method is a little code you can call to test to see if a string is equal. One string is equal to another. So let's take a look at the code. So you can this code's gonna scan in a word that you type in. So we define a string, user word, okay? And then you get a system prompt, enter a word, and then we use our scanner to input a word. Notice we've been using like next int, but now we're just going to say dot next, and that's going to grab the next word that you scan in. So scnr dot next will pause the system and wait for you to type in a word or put it in the box if you're using the Zybook, right? And then that will be stored in the variable user word right here. So we scan in user word. Now we're going to test to see if it equals USA. So if user word dot equals and then USA in the quote marks, we'll print United States of America. Otherwise, we'll print out whatever word was typed in. Remember, user word is a string, and strings have the dot equals method in that class, so we can use it. So user word dot equals calls the equals method of the user word string that we've defined, and then we pass it the string we want to compare to in quote marks. So it's going to compare USA to dot equal word, user word, and then if that's true, if it's equals, it'll return true, and then we just, do the if statement there. Here's how it works actually. So the string comparison compares each character. So if you look at this, student name is K, comma, space, underscore, and then Joe, and teacher name is K, comma, underscore, Amy. And so the string comparison does a comparison by comparison of each character in the string. So K is equal to K, and notice what it's comparing. It's actually comparing the ASCII code for each character. The ASCII code, American Standard Code for Information Interchange Code, or the Unicode, the subsequent code for K is 75. So it's comparing this capital K and capital K, 75 equals 75. So those two are the same. Small a and small a, 97 and 97, those are the same. So that's actually what it's doing. It's comparing those stored Unicode values for each of the characters. Now, the nice thing about that is that they're in order of alphabet. The codes are the same order as the alphabet. So when we compare J and A, the code for 65 is less than the code for J, so we know that A comes before J. That's how we handle putting characters and strings in order in code, is because we're actually comparing the numeric values that we're storing for each character, and it allows us to order them and do sorts and all kinds of things later. But it's a character by character comparison. Now there's another way to do comparison to strings. This uses the method compare to. And actually, we'll talk about this more later, but anytime you have two classes of things, or you write two classes of things later on in your coding career that can be compared to each other, you can define them as comparable. You can say they're comparable. And strings are comparable. And what that means is that the compare to method has been written for strings. Now, this can be a little tricky the first time you see it. But the nice thing about this, if anytime you see a class that implements comparable, you know it has a compare to method. So as you move forward, if you have a class and you're reading about a class and it says it implements comparable, you know you can compare the two things of that class this way. So this is how it works. So we have string one, so one string, and we call string one dot compare to string two. And we put string two in the parentheses right there, whatever it is. It can be a string in quote marks, it can be another string variable, and we're going to compare string one to string two. Compare to compares those two strings, but what it returns involves how the strings compare. So it works like this. If string one, that's this one, is less than string two, the one you have in here, the compare to method returns a negative number. Okay. So what we want to do is we want to say, is string one dot compare to string two less than zero? So we would say if string one dot compare to string two is less than zero, then do so and so, because that means string one comes before string two alphabetically. If they're equal, this will return a zero, and if one is greater, it'll return a value greater than zero. So you can just check and say if string one dot compare to string two is greater than zero, then that means that string one is greater than string two, comes after it alphabetically. So you can use compare to, and compare to works that way in any class that implements the comparable interface, and you'll learn about that later. Okay, each character in a string, we're learning about strings, so each character in a string has an index value. So the string Mary, have a string literal here, Mary, that I've stored somehow in memory. So here's Mary, M-A-R-Y. The M is stored at index value 0. The A is at index value 1. The R is 2, and the Y is 3. And whenever we do this kind of thing in Java, and for the most part in software engineering, we always start counting at 0. We count from 0. So there are 4 characters in this string, 0, 1, 2, and 3. So 4 characters, 0 through 3. Okay, and that kind of gets embedded in your head and thinking that way. And if we always do it that way, then it's not nearly so confusing. Okay, there are 4 characters, and the last character is at position or index 3. The first character is at position or index 0. Okay, and they're just stored. You can think of them as stored in the memory, just like this. And if you want the second one, you would go to index value 1. So we can actually access each character in a string. Now, one thing you have to remember is as we're going through this in the lecture and you're practicing this in the chapter, these very well may be things that you have to kind of figure out you need to do in the lab. So this is your tool belt we're kind of giving you here. Okay, so let's look at the how character access works. Enter a word with 5 letters, SCNR dot next to get that word, right? And then we're going to print scrambled, and it's going to print out the letters of the word, but not in the correct order, right? So it's going to it's going to print the character at index 3 first, you know. So index 3 is the 4th character. What? Well, it's the 4th character because you started counting at 0. So you just kind of have to keep that in mind. But it's going to print out all the letters. So this is how you get a character out of a string. User word is a string. user word dot character at, and then with the index value passed in, returns the character at that position in the string. Okay, okay. There are other operations that you can do with characters. So character is also a data type. Characters is a data type separate from the string data type. So you can have a data type character as well. And if you print it out like this with a capital C, character, it's got a lot of these. Now that's different than a char, C-H-A-R, lowercase. It's got a lot of methods that you can call, right? So you can test to see if it's a letter, if it's a digit, if it's white space. You can change it to uppercase or lowercase. So there are a variety of character operations available. Now, as I said, um, there's a little difference between a character char, which is a literal. Okay, this is sort of like an int. We're going to talk about this stuff a little bit more, but char is a literal character data type. So char let 0 is a variable that can hold one character. Char let 1 is a variable that can hold one character. Okay. And then we scan them in. Let 0 equals user input. Notice we use the dot next. Then we use user input dot character at 0. That's the first character. And then user input dot character at 1 is the second character in this string, user input string. Okay, so that's how you get individual characters out of a user input string if you know the position of the character you want. Okay, now we have an if statement. If not, notice this is character spelled out with a capital C. So character dot is letter, and we pass in the character. In this character class, which is different than char, the character literal, is going to convert this let 0 into this character class and test to see if it's a letter. You'll understand all that later. For now, this is how you do it. Okay, so just kind of keep this in your hip pocket so you can go look it up when you need it. How do I manipulate characters in a string? Well, this is how you do it. Okay, all right. You can also find and replace text in a string. So you can use the index of method to find a string or a character, inside a string. So say I have a string S1. That's my string variable name. It could be, I could have like string sentence or whatever, but it's string S1. So I have the string S1. If I want to find a piece of text, see if it's in there, then I can use index of. So S1 dot index of, and then I just put the text I'm looking for, the substring or target string that I'm looking for inside the string, right? And it'll return the index. Okay. If it's not found, if that text is not inside of S1, it'll return a -1. So say we have this internet address, okay, and so we want to find the index of the domain. So the domain of an internet address is like the .com part or the .edu part, that kind of thing. So we scan in the internet address, the user's email address right here. We scan it in. Notice this is the next line. Next gets a word. Scanner.next gets the word. Scanner.next line gets an entire line of text until you hit the enter key. Scanner gets a word because it stops at the space. Scanner.next. Scanner.line stops at the enter key. So in this case, we want the whole thing. So index domain equals username, index of, and then here's the substring we're looking for, .com inside parentheses, right? So if domain index is not equal to -1, remember -1 means that index of didn't find it. So if .com is in that string, it's going to print out .com found at index and then print the domain index, tell you where it was found in the string, right? Okay, look at that for a minute. Let that sink in, work your way through it. You can always kind of play around with this code, type it in a little bit, but these these exercises are in your Xi book, so it kind of works you through this stuff. Last index of returns, it works the same way, but it returns the index of the last occurrence of the text in the string. So it's the one that occurred last. Okay, so you may need that at some point. A substring is a contiguous part of a string. So if I have a string, hello world, right here, okay, world is a substring of hello world. And if we're looking for it, it becomes our target string that we're looking for, right? WRLD is not a substring because it doesn't exist in there in that order. Those characters don't exist in that order. Substring is also a method to get a substring of a string, right? So if I want to pluck out a substring in a string, I can do that. S1 substring, and I give it the starting index of the substring that I want to get and the end index, and it'll return that substring from the string. Okay. And this is just a little code that's sort of showing how to do that. I get the index of the ampersand in this line, okay? And then user email, that's the email, dot substring 0, and then the index of the ampersand. And what's that going to return me? That's going to return the username. Like in an email address, it's going to be xxxxxx at such and such. So this would get me everything before the at, right? From 0 to the at symbol index. So I use substring to pull that out. Index 0 to whatever the index of the at is, right? And then I can grab that out of there, and I know that's going to be the username in the email address. Okay. So the replace method of the string class can be used to replace text in a string. And you just call it this way. So here's the street address as a string, dot replace, and then the target that you're looking for and what you want to replace it with. And that's it. Pretty straightforward. A conditional expression, you don't have to use this if you don't choose to. It's totally up to you. I rarely do, but a conditional expression is a shortcut way to replace an if-else. And basically, you use the question mark and the colon. So my var equals condition, question mark, expression 1, expression 2. Expression 1 is what happens if the condition is true, and expression 2 is what happens if it's false. It's a quick way to write this if-else combination on the left. So it's a shortcut way to write that. So this is important. Floating points can't be directly compared for equality using the equal sign. And I'm going to show you why. So if we look at this code, we have num meters equals 0.7. Okay, so we're setting num meters equal to 0.7. So num meters is probably a double, right? I mean, we don't show all the code where it's been declared as a double, but it's equal to 0.7. And then we subtract, we have num meters minus 0.4, and we save that to num meters. And then we subtract 0.3 from num meters and save it back to num meters. So num meters 0.4 plus 0.3 is 0.7. So if we subtract those two values, num meters should be equal to 0.7. In fact, it's not. Because of the way floating point numbers are stored in base 2 inside your computer system, it's not going to be exactly 0, possibly. And in fact, if you do this, it's actually minus 0.0000 and so on, 555,112. So this is a very small negative value, right? And so it's very close to 0. It's in effect 0, but it's not actually 0. So if you do the comparison with the equal sign, like you would compare a couple of numbers, it's gonna come out not equal to 0. That's not what you want. You're testing to see if it's 0, and it's so close, you want it. That's 0. That's effectively 0. So here's how we do it. you subtract whatever you're testing. Say it was 0 or 7 or whatever you want to test num meters for, you subtract it from num meters. So num meters minus 0. Now, we expect that to be very close to 0, right? Because num meters is this thing that's so close to 0. So that's going to come out minus this value. And so we subtract this from num meters. We take the absolute value of it. What does that do? Well, if it's negative, it's just the absolute value, whether it's negative or positive. It returns a positive number. So it's going to, in effect, make it positive, right? And then we check to see if the difference between num meters and 0 is less than some value. So we subtract 0 from num meters, and we check to see if it's less than 0.001. And it is. It's this really small number over here. So if that's the case, then we're going to treat it like it's equal to 0. If it's not less than 0.001, that means something else is happening, so it's not equal to 0, right? So if we want to know if it's equal to 0, we have to do this business with the absolute value, subtracting it, and then checking to see if it's less than some error or epsilon over here. Okay, that's how we do it. So you can see it here. So we have this if-else statement, series of them, and we're checking body temperature. So we want to know if the body temperature minus 98.6 is less than 0.0001. We're testing to see if body temp is equal to 98.6 right here. Okay, and that's how we do it. We subtract it, take the absolute value, and check to see if it's less than some epsilon or error value. And if it is, we're going to call it 98.6, and that's normal. Okay. You don't have to do that if you're doing greater than or less than. You don't have to worry about it. Just when you're checking equality. All right. And here's really at least part of the reason. This is IEEE 32 point floating point representation. And this is how floating point numbers are actually stored. They're stored as a kind of scientific notation. So this value is like 1.1 times 2 to the fourth, okay? And this is the way we store it. We store it in this 32 bits, okay? The first bit's the sign. The second bit represents the exponent of the scientific notation in base 2. And the third part is that part that you multiply times that exponent. You don't need to know about this right now. We cover this in pretty much detail in computer architecture, which you will get to, but for now, just as a general explanation, this doesn't result always in an exact value, and so that's why that goes on. All right, a couple more things, just kind of quick. The short circuit evaluation. So this is an and, okay? This is an and. And what do we know about an and statement? Well, they both have to be true for this to be true, right? So the only thing that gets evaluated, if this first expression is false, evaluation stops there because the system already knows it doesn't make any difference what the second one is. This is false, okay? So that's short circuit evaluation. And that makes it, that makes the operation of the system more efficient. Okay, so we covered quite a bit in here, but the main part of this has to do with if statements and strings, right? So if statements allow us to have branches in our code to make decisions in our code. If the elevator weight is greater than 5,000, shine the warning light and don't move the elevator, that kind of stuff. That's the sort of code. Um, we also learned about relational operators, Boolean operators, Boolean variables. Um, if is raining, don't ride your bike. Is raining being a Boolean variable, it can be either true or false. We learned about switch statements as a way of creating branches, testing for equality in strings, among other string things like searching for substrings. And we learned how you can't test the equality of two floating point numbers, doubles or floats, using the equal sign. We have to jump through a little hoop and subtract the two, take the absolute value and check that it's less than some error. Okay. All right, good. Now, I would suggest that if you can finish this unit relatively quickly, you go ahead and move into the next unit. The next couple of units are contain a little bit more information, may cover more than one chapter. Okay, good. Doing great.